So let's see what's changing actually when we click on this circle here. If we drag it to the left, you can see in the inspector underneath transform, the Y rotation is actually the thing that's moving. So that's probably what we'll want to change in our code. In our player controller class, we already have this bit of code here where we're moving left or right. Let's see, well, if we are using our vehicle's transform, then we'll need that transform component. Now let's see, luckily, because my IDE suggests different methods that I can use, well, there's this one method called rotate, so it'll actually rotate it at an angle. Well, let's just see what it does. So if I click on the rotate method, and then I type an open parentheses, it suggests different things. So it wants a vector 3, Eulers, an axis, and a float angle. That one seems pretty useful. Well, we know that the axis is that y-axis, that vector 3 up. So actually, vector 3 dot up. And then it wants the angle. Well, we kind of already calculate an angle here because of our turn speed. Let's just see what it does. So if we select our time all the way down to our input in our vector 3 dot right translate, if we cut that out with Control or Command X, in our rotate method, after the comma, make sure to paste the entire line of code in there. We're going to put the semicolon to close that statement, and then we just delete our translate there for vector 3 right. Now if we save, we'll see if that works, if that was what we're looking for. Now when I press play, if we watch the vehicle in our game, as I drive forward, I'm turning left and I'm turning right ever so slowly, but I'm turning, so that looks pretty good. So what we'll actually do is, if we select our vehicle in the hierarchy, we'll turn the turn speed up to like 25. We'll see what happens. We're just testing anyways. Now we'll play again. There you go. Now it looks like our car is really driving down the road. That's awesome. Look at it go. Just driving all around, avoiding all those obstacles. One very cool thing to note, so in fact, if I actually go in my scene view, and I'm going to keep play on here just so we can kind of see what's happening. So you can see in our game, as I move forward, it always knows what direction it's moving forward. Now, we've been moving all of our objects in our scene, if we select our move tool, based on the global position of things. So we're always doing it based on 0, 0. Our Z arrow will always go positive in the Z. Same thing with our X arrow and our Y arrow. But at the top left, next to all of our tools, you'll notice this button here that says global. In fact, if we actually click on global, we can set this to local. Now, let me get a better angle so you can kind of see what's happening. So as I turn the vehicle, make sure you have the game selected. As I turn the vehicle, you can see that the Z is changing, and it's always pointing in that forward direction. But then, if I switch this toggle back to global, you can see that the Z flips back to the positive Z direction of our world. So, when you're trying to position things in your world, it's helpful to have that toggle set to global. But then when you're testing things, like if you want to make sure that your object is facing the right direction, you can toggle it to local, and then you can see which way your object is pointing while you're trying to interact with it. So that's very handy. Very helpful tip in case you ever need it. So what you're going to do is in your player controller script, down where you were transform.translating by vector 3 right, you're going to create a new line of code underneath it, and we're actually going to use our rotate method on our transform component. We need the axis that we're going to rotate it around, which in this case is our up axis, and then we need the angle that we're going to turn it at, so we need to make sure that we're calculating it based on time instead of every frame. We just multiply by that turn speed, and then we multiply all of that by our horizontal input. And then when I save, back in Unity, you can select your vehicle, play around with the turn speed and the speed, so that way when you're pressing play and you're testing your game out, you can see how fast you're turning and how fast you're moving. And you can set it to whatever feels good to you. Now it's your turn.
Okay. Alright, so we're just going to get rid of our right and actually make it into a. Good. Alright. Just head over yonder. Okay. Alright. Forward input. Okay. Alright, so. So. Okay. Alright. I think that's correct. Um, let's see if it works. Something's happening. Forgot a word. I forgot a word. Forgot a word. There we go. Corrected. Oh yeah, I gotta. Forgot about the speed. So I'm going to do my experiment and do 25 and 35. Ooh. Whoa. Ooh. Oh, Let's try it again. Oh, sorry. Let's try it again. Ooh, that's hilarious. But I'm happy with that for now. Okay, save. And now let's put you back. Mark is completed. Alright, let's clean our code and hierarchy. And then we're done. We added lots of new stuff in this lesson before moving on. And the hour is. Oh, it's been over an hour. I didn't know it was over an hour. Okay, we added a lot of new stuff in this lesson. Before moving on, to be more professional, we need to clean our scripts and hierarchy to make them more organized. Let's find out how.
Now our game looks really good. Our player has full control. We got rid of that weird turning issue we had. So now we can actually just turn instead of sliding around the road. So what we're going to do, last but not least, is we're going to clean up our entire project so that it's nice and organized. Luckily, we've done that already in our project window with all of our folders. We have our scripts and we have our assets in our library. We have our scenes, so we don't have to worry about any of those. There is one bit of cleanup here in our hierarchy. We have all of these obstacles, and that's kind of disorganized. It also will clutter up your hierarchy very quickly. So we can actually take a tip out of our environment here. So you can see actually there's 3 other objects under our environment for our road, our sky dome, and our mountains. So what we're going to do, we'll collapse our environment. If we right click on the hierarchy window, we can scroll down to create empty. So this will actually create an empty game object in our scene that we can't see. It doesn't exist. If I click off of it, there's nothing actually there. If I click back on the game object, there you can see it. So we'll actually rename this obstacles, and I'm just going to select the name in the inspector, rename it obstacles, press enter. So we can use empty game objects to just keep track of all of the different groups of objects in our scene. In this case, I'm going to select our first obstacle, shift click to the last obstacle, left click drag all of those into that empty game object. So now all of those game objects are nested underneath that empty object. Later, we'll be able to really use nested game objects to their full power, but at the very least, we can use nesting of game objects, so our parent empty game object can just group together all of our children game objects so that our hierarchy is nice and organized. So if I collapse this, now it looks a lot cleaner, but if I ever want to go see all of my obstacles, I can click on the arrow next to it, expand, and see all the different obstacles that are there. So that's super helpful. Now, we're going to clean up a lot of the code in our player controller script. So first, we don't need these public variables anymore. We already know the values that we want to use. So we'll make them private. That way, whatever we change inside of the inspector doesn't have a different value inside of our script here. One thing we do need to do, we never actually set turn speed, so we'll need to initialize that. So I believe we had something like 25 or so. We can always change it later if we need to. We can even add some comments, so private variables, so we know that this is where all of our private variables are. In our update method, we can also add some comments. So we can add, this is where we get player input. We can change this comment because we did make the vehicle move forward. And we can add another comment underneath. We turn the vehicle. And then we save. So that way now our code is a lot more readable, very organized. We know exactly what we were trying to do. And then if we want, we can do the same thing for our variables in our follow player class. In this case, we're going to keep our game object public because we actually gave this variable a reference in our script in Unity. So if we actually turn this to private, we won't have that reference anymore and we'd actually break our camera. So what you're going to do is in your hierarchy,